While we're waiting for the furniture to arrive, I want to ask if anybody has a quantum project underway at their organization. Show of hands. Who's working on something in quantum? Okay, all right, good. The other thing I want to talk about is workforce, while they're bringing in the tables. So a topic that doesn't get mentioned that often is the need for adjacent and ancillary skills. Certainly we're talking here at the Abu Dhabi port, the Maritime Center, the Academy. There, as you could see by the awards even, there's a range of talent, of skills that are needed to run these kinds of organizations. I think it often gets overlooked. People are like, well, do I need to be a condensed matter physicist to work in quantum? And the answer is no, because these organizations and or businesses need people with lots of different skills to help them grow, drive the business model, right? So I just want to log that with all of you. Workforce is a topic that's near and dear to my heart. I'm a nonlinear multimodal careerist. I actually wrote a book about it. I'm going to unabashed promotion. It's called Improvising Careers, Succeed at Jobs That Don't Exist Yet. This is my 8th one so far. So that said, let's talk about quantum technologies for safer marine operations. All right, the chairs are here. We need microphones, though. I want to invite Dr. Dmitry Mikhaylov to join me. Hello. Thank you. And Kieran N Bjergstrom. Yes, thank you, gentlemen. Here we go. You all have mics? All right. We're ready to go. So standard protocols, I asked people to introduce themselves briefly rather than having me read from a CV or point you to LinkedIn or to the corporate website to get more information. But that said, could you just share your name and your role and what your organization does briefly?
Dr. Dmitry Mikhaylov, I'm head of research. I'm in charge for bringing new technologies to Abu Dhabi ports, and basically I'm one of organizers of this conference.
Well, thank you just for your support in putting this together.
Yeah, thank you very much. I have a couple of hats, as those who know me well will have heard before. I'm director of a company called Quantum Technologies Associates, based in the UK, and we're an engineering house focused on systems engineering and hardware productization for quantum. I'm also the quantum lead for the Royal Institute of Navigation, which covers everything to do with safety of life for sea and for air, position, navigation, and timing. And I'm an associate director at a company called NLA International, which is a maritime domain blue economy company.
And the question it begs is, do you ever sleep?
Not if I can help it.
Probably not that much. Okay, let's talk about sensing, communications, and computing. So Dr. Bjergstrom, how would these technologies influence the maritime industry and change its approach, particularly to safety and resilience? And those are 3 broad topics, but
a very wide question. I'll try to stay at a high level before sort of diving in. And I'm also not quite going to answer your question, which is a terrible form.
That's fine.
I think it's worth just reflecting.
Share insight with the audience, right?
I think it's worth reflecting on how the maritime sector is changing. Because, otherwise, why do we need a quantum solution? What's actually driving new demand signals? And I think that's several-fold. One is a increasing complexity to the maritime space and the blue economy. There's a significant increase in infrastructure in the sea space. It's a more complex area to navigate safely, and there are more economic modalities in the blue economy that depend on connectivity and that depend on advanced systems. That presents one need axis for quantum. It's also a more threatened domain than ever before, with geopolitical concerns resulting in jamming and spoofing across wide areas of sea, across key shipping lanes and key choke points. So there's a need for resilience that's far greater than it has ever been. And I think those 2 things in particular drive the role of quantum today and in the future, and that's a role that enhances our security but also enables economic prosperity. Which areas of quantum? All of them, in one way or another.
But so can you prioritize? I mean, or where do you think there's traction early on? Obviously, the conversation around post-quantum cryptography and Q-Day, is top of mind for every organization that's collecting and rationalizing data that's not going out of business anytime soon.
I think we've heard very compelling arguments around communications and around computing. There was a few excellent slides earlier showing all of the use cases for computing, and I think they may remain extremely relevant and impact sort of the commercial bottom line for shipping organizations and wider maritime organizations. Sensing, I think, has been touched on less so far and presents near-term opportunities as well. That is particularly in provision of resilience. So one thing that the future of the maritime sector depends on, and I think we'll take for granted, is ubiquitous communications. It's the ability to talk to platforms at sea. Those may be crewed platforms, but they will probably more likely be autonomous platforms, new forms of energy generation, new forms of infrastructure. And that guaranteed communication currently ultimately depends on satellite signals and depends on GPS. And we see across domains that that's not a reliable and a resilient dependency. So local quantum position navigation and timing systems, particularly timing systems, local clocks, I think there's a very near-term application there which will significantly enhance resilience and is probably an enabler for complex autonomy, including, for example, mixed manned and autonomous traffic.
Wow. And I want to talk about GPS-denied environments and how that impacts shipping, but let's save that for later because I want to go to Dr. Mikhaylov. So you sit in a unique position. You're here at AD Ports Group, so doing this every day, like in a real world setting, right? IRL. So which operational challenges in maritime safety align most closely with, say, quantum and AI in this case working together?
Well, basically, as my job is being head of research, and I'm wearing two hats, right? I'm a scientist, so I'm very excited with what we are doing here, what we are discussing, but at the same time, I'm very hard pushed by management to bring some technologies that bring revenue and make our operations efficient. We have 300 vessels, and what I do, basically, I try to understand what are the technologies that are ready to push our efficiency now. And speaking about the topic that we are discussing today, of course we discuss cybersecurity, it's important. We are pushed by cybersecurity regulations, and we had this UAE Cybersecurity Council head who was giving the speech in the morning, right? It's quite clear. Yep. Sensing is not being discussed a lot, but sensing can bring a lot of efficiency, and quantum sensing can bring a lot of efficiency because Abu Dhabi Ports is opening a very big new vertical that's called underwater mining that is essential and hopefully it'll generate a lot of money for the country itself. You know, we have a lot of nuggets laying on the ground floor, on the floor of the ocean, and currently there are not enough technologies, there is not enough technologies that can really help us to identify the best reserves. We have great fleet of 300 vessels, and we're exploring the quantum sensors, gravitometers mostly, that can start generating revenue for us today. This is a second topic that's very important and relies to the sensing technologies. And optimization, we also discussed a lot about optimization, about quantum, probabilistic optimization. It also can bring a lot of revenue to Abu Dhabi Ports now, but for this we have to implement artificial intelligence properly first, and for that we have to collect quite a lot of data. Yeah. So I have to be very practical with my job, and these three verticals in quantum can generate revenue for Abu Dhabi Ports and are in focus for Abu Dhabi Ports now.
Yeah. So so the project for deep sea mining? What are you mining? What are the what are the nodules? Or can you share what that is?
Yeah, sure.
Is that a proprietary piece of data?
It's not. Okay. It's mostly cobalt, nickel, magnesium that we have, potash as well that we want to bring up. We have smelters, as you know, it's in Abu Dhabi Ports in KZ industrial zone, and we have to fuel it with these nuggets. So far, it's not industrial. We are just trying to identify something in the region of influence of Abu Dhabi Emirates, in Mauritius, Tanzania, in Comoros Islands. They have a lot of reserves. Yeah. So we need very reliable tech to identify these reserves, to make it very environmental friendly. This exploration has to be very environmental friendly. We don't want to put a lot of robots under the water where they don't have to be, and we have to identify them in time. So this is the big revenue stream, and if you ask me where you have to focus as quantum researchers, I would focus on gravitometers that can be put on boards or on robots to identify these reserves, because in this case we are ready to invest in this. It's super interesting and brings us a lot of efficiency.
Great, that's a great insight. Thank you for sharing that. Dr. Pierce, I want to talk about solutions that are sort of vertical agnostic to some degree, because based on where you sit, you would have a perspective on this. So are there, technologies, quantum solutions in other industries, other verticals that could be exploited in maritime settings, maybe anomaly detection, predictive fleet safety, seabed mapping, as Dr. Mikhaylov was talking about? How might we leverage other work that's going on? I mean, the traveling salesman problem has come up several times.
I think the points on computing are clearly there. There are parallels in the optimization problems in the maritime sector to those in the land and terrestrial domain. So I think that's a matter of porting things over, and we can learn a lot from the sort of prototype activities that have already been done. The mapping problems that we're talking about for the maritime sector also exist for the land domains. So, for example, mineral exploration, flown gravimeters and flown magnetometers to try and find deposits of key minerals and inform mining activities. It's analogous to the subsea problem, and it's just as relevant and just as important. I'd also just want to broaden the gravimeter point Dmitry was making, because it's much more relevant than just underwater mining. It's relevant to providing new means of positioning, particularly if you have subsurface assets. And I think we'll see a lot more traffic under the sea. As autonomy goes out, we're looking at autonomous platforms that will do maintenance tasks on all of the energy infrastructure, for example, out at sea. And that's not going to all be surface traffic. It'll be underwater as well. And they need to know with very high certainty where they are. And that's positioning against gravimetric maps and potentially magnetic maps. It's also sort of new and emerging use cases like blue carbon capture, seagrass monitoring, cases like that. It's very hard to perform large area surveys for captured carbon on the seabed, but that is something that you can capitalize. You can issue blue bonds against that, and gravity sensing opens up some new pathways for that monitoring case. That's already traded with traditional monitoring methods on carbon markets, so the market pull is there, but the survey methods are very poor. And when you consider that this is typically a yield over time, you need to be able to reliably, consistently monitor carbon capture. So another interesting way for gravity sensing. I'm supporting your point on this one, really. I think that's a top priority from the sensing domain.
Yeah. I want to talk more about communication. So we saw great demos from IDQ and from Quantum Gate. The controversy around QKD and PQC is sort of the elephant in the proverbial room, if you will, to some degree. I want to ask your take based on where you sit. You're in a role that's trying to monitor and manage these potential solutions in a way that drives the business model. Can you share your take on both of these approaches and how you might be using them in your day-to-day work here at AD Ports?
For cybersecurity, I mean, right?
Well, like, PQC and QKD, where they fit in your business model, if you will, or in your communication strategy.
For communication strategy, again, this is more RegTech for us, if we are pushed from the regulators to provide better solutions.
Regulators, it's more and more, right? It's
unfortunately, to be very frank, it's all the RegTech, right? We are in accordance with all regulations, but it's something we spend money on. It's something we have to do and we will do. But at the same time, to show broader to the stakeholders of Abu Dhabi ports that quantum technology can generate revenue, we have to add some more streams that really generate, like undersea mining that I mentioned, right. Predictive maintenance optimization, and of course logistic optimization. So they go together. Yeah. In our case, so when we open this new competence of quantum, we show that okay, this helps us to go with a RegTech, but at the same time will generate revenue for this, so you can invest. And we don't want to do something from scratch in Abu Dhabi ports. We want to partner with relevant partners who already have the tech, but the tech is less than half of a problem. The biggest problem in our case is how to implement everything inside such a gigantic organization and how to win all the stakeholders.
Right, back to the workforce conversation. But so are you getting guidance / pressure from senior management to come up with solutions for protecting and securely communicating information possibly using quantum technologies?
Really?
Hope your boss isn't here. Oh, no, he's left, I think, so you're safe.
They're very public company, right? And when we speak to the group CEO, he's always like insisting on growth of the company itself. He says, anyway, whatever is, there is nothing not a lot of secrets in Abu Dhabi ports. We publish this information quarterly because we are a public organization. So he's more pushed by how to generate more revenue, and we like everything about how we structure our activities based on these KPIs. And that's actually why I'm very frank about it. It's just for all our participants, all the companies, I just wanted to convey what drives our decisions and how we make these decisions on investment and partnerships and implementing. And just to add a little bit, the group itself is quite big. We have 300 vessels, multiple ports globally. So being efficient and bringing even like 1-2% of efficiency for Abu Dhabi ports means we generate, as Abu Dhabi Maritime Academy, we start generating a lot of money. I'll give you an example. We have 300 vessels, and we spend about $600 million on fuel every year. So if we save even 1%, this is a revenue that partially comes to us, and we can redistribute it with partners, fueling them to bring more and more solutions. So it's very easy. If we want to implement something, let's get very practical. Let's speak about numbers inside such a big group, and we'll all get very good contracts.
Yeah. So again, staying on the topic of communication. So Dr. Bjergstrom, I want to get your take on, how you place the readiness of quantum communication systems to improve safety of maritime operations, maybe in the near term. How close are we? I assume it's going to be incremental as, any early technology gets adopted. The William Gibson quote, "The future's already here, it's just not evenly distributed." So where are we with sort of quantum-based communication readiness for maritime applications, in your view?
So I'll take a seaside view rather than a landside view, as I think some of the previous conversations, the demo actually showed brilliantly what you can do on the land today and regionally with QKD networks. There is a future is now aspect of that. Resilience and resilient comms at sea is critical. That's going to be necessary and underpinning. That's true for autonomy, but let's just explain the density of the sea space a little bit. In the UK, we expect over 75% of our sea space will be filled with infrastructure within the next 10 or so years, non-navigable. Meanwhile, we have the Channel Straits, one of the busiest shipping lanes in the world, and we have a great variety of ship traffic, not just large container vessels or tankers, but also pleasure craft, autonomous craft on the surface and below the surface. So this very complex and very busy area that has less and less navigable space and more risk. What we don't have in the maritime domain, as you have in the aviation domain, is an equivalent to air traffic management. There are views to that, sea traffic management and e-navigation, trying to coordinate that traffic in a much more explicit and mandated manner. And I think that inevitably, as we have more complex mixed traffic, the industry will move in that direction. As that happens, guaranteed comms and guaranteed secure comms is fundamental. It has to be ubiquitous, and it has to have a very high level of integrity. And quantum communications is necessary there in several forms. That may be the ability to have ship-to-ship communications and ship-to-shore communications, but it's probably more so actually about ship-to-space and space-to-ship. And it's that space link that's going to be integral, that satellite link. This is also why QKD is so important, I think. There was a PQC versus QKD conversation, and one area where I see QKD as fundamentally advantageous is when you're bandwidth limited. And when you're talking about space to vessel communications, you do encounter those bandwidth limitations far more readily. And I think the importance of QKD is therefore emphasized. If you move this into a defense and security context, that's even more true, because your operations would be desirable to be as silent as possible. So I think there the emphasis on quantum key distribution becomes very apparent, and there's a real criticality. As for the maturity, I think there's more to be done. Free space QKD to space is something that's demonstrated, but I don't see that as something being piloted in an operational context quite yet. I think a lot of the free space QKD demonstrations show what is possible. So we're moving in the right direction, but I also think there's some years ahead on that one.
Great. No, thank you for sharing that. Dr. Mikhaylov, I want to ask you about deploying innovative bleeding-edge solutions, right? So particularly quantum in this case, but contention is it requires bridging innovation and adoption. I wonder if you could share insight or guidance with our audience, like how to approach that. Obviously, generating attributable revenue, but and it's org management, it's resource conversations, it's in addition to funding.
Well, it's quite a process. It's super interesting. It's my everyday job.
Yeah.
So first, you form a use case. You have to inform the top management that it will generate some revenue. Not even now, just in a couple of years, it's okay. But it has to be profitable. And it's number one. Number two, and we are blessed with this place because we have classes for young captains that are brought by experienced retired captains. You have to win their hearts. You have to speak with them because they really know what's happening on the ground. And it's like next door. You bring the technology, you speak with a real captain, and then he says it will never work because you've never been on the vessel. You don't know how it works. And then you start speaking with them and winning their heart, what would really work in the real environment. And we are also, the group CEO is a captain. And when you come to him and say something that's not relevant to real people on board, he will immediately cut the budget because you have to be very practical. And the third one, it is the toughest one, it's when you come to class societies. You have to speak with them because they give you the ship passport, just to make it short, right? And they're very strict. Whatever you bring as an innovation, you have to spend 70% of time speaking with them and proving them that it will not influence the ship, the security, the safety aspects. So you have these three things that you have to do before implementing the innovation. It takes a lot of time. And just to be real practical, to get money on and we all want to have good contracts, right? To implement something in Abu Dhabi ports, we have to work together on working with these three stakeholders of innovations. And it's not easy. This is a very reserved area. But now, if you find good captains who are very enthusiastic, who will explain how will it benefit, if you start speaking with accounting department on how you will win the numbers, if you build good relations together with us, with class society, because they don't belong to us, they are external. If we win these three pillars, the innovations will flow, and we have great turnovers because of the size of the Abu Dhabi ports. But for me, what is toughest in my job, most of the partners coming to me and say, okay, please buy this, or please have this solution. Yeah. I can do that, but I have to spend like years on persuading these three stakeholders. If we do it together, believe me, we'll have excellent implementations very fast. But we have to be on the same side. Yeah.
So sort of following on the theme of it takes a village and earlier conversations about this is a team effort and it's a community for sure. Dr. Bjergstrom, I want to ask you about collaboration. So what models of partnering, say, between research institutions, industry, maritime operators, maybe academic settings, have you seen to be effective in bringing quantum solutions, in this case, to real operations and maybe specifically in maritime settings? Like, is there training going on? Is Loughborough offering courseware in this kind of topic?
So that's a really good question. I think that it's a very hard one to answer. There are pockets of excellence, but I don't think anywhere does it comprehensively, overall, brilliantly just yet. I think we've seen, and the NOC in the UK is a good example, we've seen strong centres of excellence tied to major ports providing a bridging pathway to innovation. We've seen that in robotics and autonomy very well. We've seen that in future energy technology. So I think there are models that the maritime domain have sort of established that we could apply to quantum. I don't think there's something explicitly maritime focused that's performing that bridging role just yet. And I think actually events like today are sort of cultivating that understanding and creating that opportunity. It's really important, and it's sort of the point you were making, Dmitry. Just because the technology is good doesn't mean it can be procured. There's an important concept of procurement readiness in, I think, the maritime and aviation sectors, and that goes beyond the technology readiness, and it goes through to end-user trust in your system, the heritage of the businesses delivering and integrating this capability. It goes through to the regulatory context, standardization and certification. How do you assure your system? What's its supply chain? Do you know we can maintain it for 25 years and continue to get repairs? Is it retrofittable? All of these problems are far less understood than the nuts and bolts of a warm vapor clock that may provide you timing holdover if your GPS jammed. And you're not going to sell those systems, certainly not in volumes, across fleets until you can start to address those questions. So I think investment and activity there, support there, is really vital if we want to realize the economies we start to see and discuss today.
Yeah, no, that's great. So I think we're coming to the end of this section. So I just want to ask a final question. Assuming we make it through Q Day, looking back, what single breakthrough in your area of expertise would say best demonstrate that quantum has arrived, has become an essential part of maritime safety and resilient operations? Dmitry, what's your take?
Well, we are doing good job in Abu Dhabi ports in implementing artificial intelligence for all our operations in optimizing logistics. If at least one use case out of all this use case we are implementing now, will work on quantum within the next year, it will be great win. It will be real application of quantum in logistics.
Logistics, you think, like an optimization?
For now,
logistics
yes,
example.
because moving from AI to logistics is quite
Yeah, yeah.
simple.
I'll have to choose a different use case.
Yeah.
I'll go for resilience against GPS jamming and spoofing then. I would say timing devices and local position and navigation devices that can realize an economy of scale such that they're not just deployed on high-value bespoke vessels, but you see them across the shipping fleet, across the cargo fleet, at a price point that makes that possible. As often as you see a GPS receiver, you see a local quantum clock that provides you coverage when you're jammed or spoofed. That would be an enormous marker of success.
Yeah, so great. So do we have time for questions or no? Yeah? Okay, yeah, so questions, an opportunity to query two large brains. Should we give you a mic? Sir, hang on a second. I want to give you a microphone so everyone can hear what you're saying.
That's a very interesting point because spoofing, I mean, it is also done by some people only. And what I used to think that, you have a DGPS where you have a differential systems fitted ashore, which can correct that as per my technical understanding. But apart from that, what you suggested, quantum clock, can it be integrated in the current infrastructure?
Yes, it can. So let me give a point on spoofing, actually. Civil spoofing is a really new threat vector. 10 years ago, there weren't civil spoofing attacks. Nowadays, it's ubiquitous in the maritime domain, and in the aviation domain, there are over 1,000 flights a day that suffer spoofing. And because of some of the low-level vulnerabilities, that results in bricked GNSS receivers that need refitting on landing in about 12% of cases. That's the scale of cost of this issue, and it's a new problem. We've just seen some examples. They were shown at a conference in the public domain very recently that you can now perform spoofing and jamming on a continental scale from space, and that's been shown as a real threat that has been demonstrated in a very limited context. So the risk is here. Can you mitigate it with quantum clocks? Yes, you can also mitigate it in other ways. SERPAs, especially controlled reception pattern antennas, which used to be trade controlled by America. It was taken off the ITAR list a few months ago, so you can now buy that, and you'll see fleets are fitting them. But quantum clocks enable you to maintain timing holdover when you lose your GPS signal. That's the most important thing for a ship. It gets its time from GPS, just as your ATM readers or your bank card readers at shops get their time from GPS. And that is central to the entire bridge system. The moment you lose time, your system fails in a complex way, and there have been many trials that show ships essentially failing fundamentally when they lose time for a prolonged period. So a clock gives you the basic holdover. You maintain functionality, the ability to navigate, the ability for your bridge systems to work. That is critical to safety. Of course, it doesn't fix your navigation problem just yet, but it enables you to communicate, because if you lose that time signal, you can't synchronize your communications. So you lose that core link to shore or even ship to ship just for local triangulation.
Suggesting fitting on the instrument on the ship or...
Yeah, local timing holdover on vessels. Chip-scale quantum clocks or board-scale quantum clocks, yes.
But worth mentioning, there's a company, Q Control, I think a gentleman's going to speak from that, and they're doing amazing work in GPS-denied environments for aeronautics, for planes, right? So hopefully you'll talk some about that at some point.
I'll give a brief, thanks for the introduction.
Yeah.
Yes, and I'll also give a brief intro on the work we're doing with Maritime also.
Okay, fantastic. When is that? When are you speaking? Is it later
I think
tomorrow?
3:30.
3:30, okay, good. Mark your calendars, yeah. So this is a vital conversation for sure, important, and that company's doing great work in that space. Other questions? Don't be shy. You're among friends. There won't be on the test. Really? More lunchtime? Yeah, everyone's ready for food. Okay, well, if no one's going to ask any other questions, we'll call it a wrap, and I want to thank these gentlemen for sharing their insight and perspective.